Hi, hello everybody. So this is the second video dealing with section 9.1, the ellipse, and this is the video where we're going to do the translations uh, on the ellipse. So that means that we're going to go from the origin 0, 0, and we're going to go to a location where the center is at HK. This is very similar to what we did with the circle. Now, if you remember, the equation of the circle is x minus h square plus y minus k square equals r square. Now, the invisible denominator is 1, so that's why you know it's a circle, and the center is at hk. Okay, so this is exactly the same thing we do with the ellipse. If you recall, this is now the complete equation of the ellipse. In this case, the ellipse is centered at x, or it's sitting on x. The major axis is the x-axis. And in this case, the ellipse is sitting on the y-axis, right? The major axis is the y-axis. Everything else is the same. The only thing that's different is now the center is HK. So when we find the four key points and the location of the foci, we have to take into account that the ellipse is no longer at the origin. Okay, so it gets a little bit more involved, but nothing too complicated. So let's do the first two problems that we have. Now, they're taken from your textbook, obviously, and they are both already in standard form, right? So this is in standard form, and this is in standard form. So now just keep in mind that the questions that we have to practice are the ones that we have to find the center, the four key points, and the foci, okay? So your textbook is only asking for the foci, but we have to find all of these things. So let's do the first case. So in the first case, I noticed that the denominator on the y is bigger. So the ellipse is sitting on the y-axis. That is its major axis. All right, so let's see if I can do this. All right, so just bear with me because using this software is a little bit difficult. Here's the center, no longer at the origin, right? And the center is, right, you invert -1, you invert +2. So the center here is 1, -2. So I'm going to write it over here. And now I have to find the two vertices, the two foci, and the minor vertices. I always find the center first. Okay. Now we take a look at where the ellipse is sitting. So square root of that value is the distance from the center to the vertex. So it's 3 units, right? Square root of 9, 3. So it's 3 units up and down from the -2. Okay, so I'm going to do this first, and then I'm going to do that. So it's 1 -2 -3 -5. 1 -2 plus 3, 1, 1. Okay. Now on the minor axis, the distance from the center is square root of 4. So square root of 4, which is 2, from the location x equals 1, right? So 2 units above 1, or to the right of 1, 3, -2, and 2 units below 1, -1, -2, okay? And now all I have to do is find the foci. So 1 is going to be above, 1 is going to be below the center. But the foci, now remember, the foci has equation c square, a square minus b square, and a square is always the larger one, so it's 9 minus 4, obviously 5, so c is plus or minus radical 5. So the foci are radical 5 up and down from the center. Now, up and down is the y coordinate. So the one above, 1 minus 2 plus radical 5, The one below, 1 minus 2 minus radical 5. That's it. That's all we have to do. So we have to account for the fact that we're no longer at the origin. Okay? So that's the first example, example 4. Let's do the checkpoint, because the checkpoint is now we are sitting on the x-axis because the denominator on x is bigger. All right, so this is a little bit easier to graph, I guess. Yeah, it looks a lot better. Okay, so here's the center. Here are the two vertices. Here are the foci. And here are the minor vertices. So we find the center first. The center is -1, +2. So it's just like the circle, we flip the values of HK. Okay, so here's my center. And now I'm going to find the vertices, which are square root of 9 units away from the center. Okay, so this is obviously affecting the x coordinates. So 3 units to the right of -1 is -1 plus 3. So it's 2, +2. And the 3 units to the left of -1 is -1 minus 3, which is -4, comma 2. Now we'll find the minor vertices, which is square root of 4 units up from 2, right? So 2 units up and 2 units down from here. So this is -1, 4, and this is -1, 0, right? 2 units up and 2 units down from here. The only thing left for me to do is find the location of the foci, which I need c squared a squared minus b squared. Again is 9 minus 4, 5, and c is radical 5. Again, right? Your book is not very, you know, interesting in doing those things. It kind of uses the same level of difficulty as before. In this case, it's just almost identical. But that's fine. This is just, we're just practicing on the standard form. All right, so because I'm on the x-axis now, I am altering the x coordinate. So my foci are -1 minus radical 5, comma 2. That's this one on the left, obviously. And -1 plus radical 5, comma 2 on the right. Okay, and that's all I have to do. Okay, there's not much else. We found the 4 key points. We found the 2 foci. We found the center. Always find the center first. All right, so those are good for practice. Now, you're not going to be given those examples on the exam. You're going to be given the ones where you have to first put the equation in standard form and then find the center, find the 4 key points, and find the foci. Don't necessarily need to graph them, but it's easier if you do. All right, so let's do the first one. I'm already going to save us a little bit of time on the video, I'm going to already pair up the x's and the y. So I'm going to write a as 9x squared minus 36x plus 25y squared plus 50y. And I'm already going to add 164 to both sides because I know I have to have the number on the other side. So add 164 both sides. Okay. Now, at this point, okay, you don't know what you have yet. So you are going to always factor the coefficient that it's multiplying the square component, whatever it is. Okay, you're not doing GCF, all right? You're just factoring the coefficient to x squared and y squared. So on the x is 9, don't factor x. You're not doing GCF. 25y squared 2y 164. Now complete the square. From here down is completing the square, just like the circle. Okay, 9x minus 2 square, right? It's always half of this number, plus 25y plus 1 square equals 164. And now we have to do the adjustment. So the adjustment is, you have to be careful because it's this number square, 4 times 9. On the y part, 1 square 1 times 25, 25. All right, so now let's see what we have. 9x minus 2 squared, 25y plus 1 square equals 225, right? Okay, I know this is not a circle because these two numbers are different. So I have to divide, I have an ellipse, which means I have to have one on the right. So I have to divide everything by 225. Okay. Now let's check to see what 225 divided by 9 is. I think it's 16. 225 divided by 9, 25. Okay, so so this thing is 25. And I think this may be 9. Or no, I think it's 16. All right, so let's see. 225 divided by 25. 9. Okay, 9. So this is 9. And obviously this is 1. Now, this is the equation in standard form. Okay, so we need to get this thing in this form to begin with. I'll make it a little bit smaller so I can fit everything here. Okay, I recognize it as an ellipse, and because the x component, the denominator to x is bigger, so this is sitting on x. So I'll graph the ellipse, center right here, major axis, foci, minor vertices. Okay, so let's do the center first. So again, for the center, +2, -1. Okay, we flip the values just like the circle. Now, the major vertices, square root of 25 away from the center, which is 2. So 5 to the right, 5 to the left. So this location here is 2 plus 5, 7, -1. And this location on the left is 2 minus 5, -1. Okay. Now, the minor vertices is radical 9, square root of 9 away from the center, but I have to start at -1. So it's 3 units up, 3 units down. So here is 2 comma 3 minus 1 and 2 comma -1 minus 3, -4. The only thing left for me to do is find the foci, and for the foci, I need to use this formula. So larger minus smaller, 25 minus 9, which is obviously 16, right? And so if you're not sure, you can always do that. Somehow, I always get stuck on that. Or maybe because I'm paying attention or something else. Very good. So it's 16, so which means 4 units to the right, 4 units to the left from the center. Okay, so here are the foci. I'm not going to write it inside the picture, not to clutter it. So now, because you're on X, the thing that's going to change is the obviously X coordinate. So I'm 4 units from 2 to the right, 6, -1, and 4 units from 2 to the left, so 2 minus 4. This is the other focus location. All right, so then we found everything. We found the center, we found the 4 key points, and we found the 2 foci using the technique called completing the square. All right, so this is on X. Now let's do the exact same thing on the other equation, which is, I think, is going to be centered on or sitting on Y. Okay, B. 4x squared plus y squared. Yeah. Let's arrange it already so that we can go a little bit faster. So I'm gonna pair up the x's and the y's. 4x squared minus 16x plus y squared plus 6y, and I'm gonna subtract 9 from both sides already. Okay, because I know I need the number on the right, just like if it's a circle. So now I am going to factor whatever is multiplying the x squared component. And the x is 4. Don't factor x. Now, in the y case, that has an invisible 1 here, so I really don't factor anything other than a 1. Okay. All right. Now I complete the square. So from here to here is completing the square. X minus 2 square, right? So always half of this number. Y plus 3 square minus 9. And here I will write the adjustment, which is on the x component, -2 square, 4 times 4, 16. And 3 square, 9 times 1, 9. All right, so now I write it, combine the numbers. And we get 16 here. So I know this is not a circle because these two coefficients are not equal. So I have an ellipse, which means I have to have a 1 on the right. So I have to divide everything by 16. Okay, perfect. So now I simplify everything by 4. Okay, in the first case. Right, this is my standard form. So part of the problem is already done. Just make it a little bit smaller so we can fit everything in here. Now, I look at this thing and recognize it as an ellipse. And because the denominator of the y component is bigger, so this is an ellipse sitting on the y-axis. Okay, so this is what it is. Here's the center, main vertices, foci, minor vertices. Now, we always begin with the center. And the center would be +2, -3. Okay. Now, we find the vertices, the main vertices first, which is 4 units up and down from -3. I'm on the y coordinate, so I'm going up and down, so it's only affecting the y coordinate. So this location would be 2 comma -3 plus the square root of 16, 4, right? So 4 minus 3, 1. And this location would be 2, -3 minus 4, right? 4 units down, -7. The minor vertices, square root of 2 units away from the center. So this and this. Now it's going to affect the x coordinate. So I'm starting at 2 and I'm moving 2 units to the right. So this is 4, -3. and the other minor vertices is 2 units to the left. So 2 minus 2, 0, -3. Okay, the only thing left for me to do is find the foci, which the location of the foci, which is this. So 16 minus 4 is 12. So now, do me a favor, do not, we don't simplify this, just leave it as radical 12, right? Now, yes, obviously, if you wanted to, you could, right, can do this. But, this is fine. Well, we're not doing, rationals, simplifying radicals here, so it's not important. What's important is you find the location of the foci. So I'm going to use radical 12 plus or minus. Now, because this is sitting on y, it's only going to affect, here's the center again. No, not that. Here's the center, right? 2, -3. And here's one foci, and here's the other. Now, I am radical 12 up or down from -3. So 2 minus 3 plus radical 12, 2 minus 3 minus radical 12. That's the way we want to leave the answer. Okay, and then we found everything. We found the equation in standard form. We found the center. We found the 4 key points, and we found the foci. So when we do that, our problem is done. So these are the types of problems, these two, that you're going to get on the exam, okay? Where you have to complete the square to put the equation in standard form and then find the 4 key points, the center, and the 2 foci.